Hey, I just recently bought myself a Tektronix TM5006 Mainframe. It's basically a box that you have modules that slide in, and you can put all heaps of different test equipment in there and build up a little test rig for yourself to do various things. There are heaps of different modules that go into these things, and yeah, you can just customize whatever particular bits of test equipment you want into one box, and makes it all nice and convenient for repeated testing and that sort of thing. And as part of the restoration and checking the calibration and whatnot of these things, we need to get some resistors. We need to put the resistors, connect them to the outputs, and then you can measure the output of the power supplies under load. So in the calibration and the adjustment procedures I've got here, we can see we've got to have a few little bits set up here. So what I'm going to do today is build a little load tester, a load bank. So I've been down to Akihabara and to eBay, and I've got a few bits and pieces. So I got this nice case from eBay, from Akihabara, and I got the resistors inside from eBay because they're cheap. 100 watt resistors, 5%. I've checked them all and they are within the 5%, so they are as advertised, so that will be perfect. I've got a switch here, which I'll go into in a second, and I've got some front binding posts to go on there as well. So what we need to do is we need to build up three banks of resistors. We need 4 1 ohm resistors in series. We need 12.3 ohm resistors, 3 strings of 4 resistors. So there's 4 resistors in series, and then they're paralleled with 3 strings. We need 3 5 ohm resistors in series, and then we need a string of 3 ohm resistors where there's 4 in a series in a string, and there's 2. So what I'm going to do, instead of making 4 banks, we're not going to do that. We're just going to put a little switch over here so we can turn off one bank. I'll zoom in a little bit just to make sure you can see what I'm talking about. If I move this all around, so you see there we've got the 1 ohm resistors, 4 of them in series, 5 ohm resistors, 3 of them in series, and these are the 0.3 ohms. So this one here we need 2 strings of 4. So if we put a switch over here, we can turn this bank of 3 strings of 4 into 2 strings of 4, and that's what the toggle switch will be for, on and off. So I've got this nice case which has got vents all over. I'll zoom back out about there. That will mean that there's nice cooling, so the resistors will be less inclined to overheat. I'll put some feet on there to space it up from the table as well, so the air can kind of get all the way around. And I'm going to space them like that. The resistors are all going to be mounted like this. So there's going to be 2 screws through the bottom. I'll use the existing holes as like spacers to get all these things lined up nice and neat, and they'll be all mounted in there. 2 rows of 5, I think, and then double stacked. And I'll have 1 spare space where there's just 1 less resistor because 1 string has only got 3. Alright, I've got all my resistors set up. We've got the 0.3 ohm ones here. They got the 1 ohms here and the 5 ohms. Yeah, it was a 5 ohm? Yeah, the 5 ohms here. And also I've gone ahead and used the old tapered reamer, this one here, just and make some holes in there. You can, if I hold on an angle, you can see them all lined up there. I didn't want to use a drill on the the battery drill because I didn't want to rip it all out, because if the drill catches, it will wander along the slot. So I just use a tapered reamer and just for all those holes, just to widen these up, because these aren't quite 3mm holes. They're probably 2mm or something. So I'm using M3 screws, so that means the screws will just drop in through those holes like that. Mwah! Okay, so that's 1/2 done so far. And come in there, jumps down, jumps across, jumps back up and out. And I've got the little loop there, that loop wire. and the 0.3 ohm, the first one of the 0.3 ohms. So we've got all the resistors and stuff installed, and the cables installed, the wires. I did make a small change, and I'm going to make another small change before it's finalised. While I was putting in the 1mm wire, I kind of had a thought that I should double check the wattages and currents and stuff flowing through this thing, and it turns out that that 1mm wire would probably act as a bit of a fuse wire through the 0.3 ohm resistors. We could have up to 20 amps. I've got it on the front faceplate here that I'm currently designing. I'll talk about that in a sec. And 13.3 and 20 amps, so 1mm wire is a little bit thin. So I've gone up to what's this? I think it's 10 gauge. 10 gauge, I believe. Where is it? 10 gauge, 5.26 millimeters squared. So yeah, I had that laying around, so I thought, yep, I'll use that. It's way overkill. I can get away with a smaller cable, but I thought, I've got this stuff, I'll use it. And for the other resistors, I used 20 gauge, which is 3 something millimeters, I think, because they're only pulling like 6.5 amps, 1.7 amps, so that's fine for the thinner wire there. So that's all done. All the jumpers between the resistors, I've used the same thickness cable. So on the 20 gauge, I use 20 gauge wire for the jumper, and then for the 10 gauge, I use 10 gauge wires for the jumpers between the resistors. So that's all good. The second change I'm going to make, I had a bit of a closer read of the calibration procedure, and it turns out there's 3 voltage rails in these units. You've got an 8 volt, you've got a plus 26 and then minus 26. They're the 3 main voltages. And one of the tests, you need to load up all 3 at once. So I need 2 lots of the 15 ohm. That's the 3 5 ohm resistors. I need 2 lots of those, which I didn't realise at the start. So I've got to fit in some more resistors, but I've only got space for 1 more. So what I'm going to do is I'm going to pull out the 3 5 ohm resistors, which are in series to make 15 ohms. I'm going to install 2 30 ohm resistors in parallel, which will give me 15 ohms, and I'm going to install 2 banks of those in the space here. So that will give me a full box of resistors. There won't be any spare spots, but I'll have 15 ohms and 15 ohms for the plus 26 and minus 26 volts, and that will be fine. So I've just got to wait for those to turn up, and then I'll be able to plonk those straight in. But that's not going to hold us up from the rest of the build, because next is the front faceplate. So I've whipped this thing up in my 3D software of choice, Rhinoceros 3D, and printed that out at 1:1. So that's going to be my drill template. I'm just going to use the spring-loaded center punch to go pop, 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 pop. And then I can drill those out to the appropriate size for my binding posts. And these are spaced at 19.1 millimeter, which is, what's that? 3/4 inch or something? I can't remember. Whatever that is in inches, it's a standard size anyway. So they're going to sit there. And then this one here has got the switch, which I have got here. Nice big clunky toggle switch, which is rated to 10 amps, which is that's 10 amps at 125 volts. Yeah, 10 amps at 125 volts. 6 amps at 250 volts. So that'll be fine, because this is only switching 1/3 of that 20 amps. So that's fine. It's switching 1 bank of the 3. So it doesn't have to switch a full 20 amps. And that's going to turn off 1 bank of the 3 banks of the 0.3 ohms to give us the 2 different resistances we need on this section here. So here's my secret to making a nice front panel. This is not actually normal paper. You might see it's a little bit shiny. It's because it's clear sticker. It's like a A4 piece of clear sticker plastic that you put through the laser printer, and you can print black and white stickers. There is a few limitations with this process. One is that you can't print white, and it's only black and white if you have a laser printer, unless you have a color laser printer or you get inkjet stickers. I've just got a black and white laser printer, but that's fine for me, because that's, it's good enough for what I want to do. So I've printed this out in 1:1 size, and that's going to sit on there like that. Those 4 tabs are going to just fold around the edges, so there's no sticker edges to fray and lift up. They're going to be folded around nice and neat. So the first step is to protect this. You've got to laminate it, otherwise that's just going to scratch off. So what I normally do is just go, and I use that to then laminate on top of there. I've got a squeegee here from some stuff, a 3M squeegee from some 3M contact adhesive I used before on another thing. So I'm going to use that just to lay this onto there and make sure there's no bubbles, and then we can stick this onto here. So I'll go ahead and put this down here. I'm going to get my head in the way and stuff trying to get this thing bubble free, so I'll be back once that's been laminated. I'll show you the next step. And the lamination is done. So just to explain how I do it, because it's a bit hard to show it on camera when my head's right over the top. Basically, the bottom piece with the printing on it, I just use a bit of masking tape and just stick it down so it won't slide around. I peel off the end of the piece that's going on the top, stick it down, and then use a squeegee and just go zhick, while I'm carefully pulling out the paper from behind and squeegeeing down the sticky plastic on top, and it comes out pretty much perfect. So the next step is to stick it onto here. So I've given this a bit of a wash. You can see it's got some still a bit wet with a little bit of bubbles on there. That's just a very, very small amount of dishwashing liquid, and that will hopefully allow us, if I've got the amount of dishwashing liquid right, to stick that down, but not stick it down straight away, and we can just wiggle it around a bit, and then we can squeegee the water out and it will stick down once we've squished it all out. So if I get this unwrapped, if I can, there we go. And now this should go down but not stick straight away, and give us a little bit of leeway to get things lined up just right. That's looking pretty good, I would say so. And it's a matter of just squeegeeing the whole thing. Another thing that I'll make sure, which I didn't quite do properly, is make sure you've got no burrs, because that will lift the sticker around the corners. I've got one just there that's not going down properly. So I might actually just get my deburring tool and go like that. And there was one over here somewhere. That's looking pretty good. Just a matter of working out the bubbles and then folding those edges over to hide the edges. And that's the front panel done. Look at that, looking pretty good, nice and shiny. Cut the holes out through the plastic for the binding post and switch, and that's going to work quite well, I think. It looks a little bit cloudy right now. You might be able to notice that. That's just a little bit of moisture in there. That'll work its way out over the next week or so and it'll clear up. But that's looking really good. So that's pretty much ready to go on our unit on the front there, and we'll put the binding posts and the switch in and whatnot. So for the connections to the binding post and switch, I'm not going to solder them on. I'm going to use crimp lugs. The reason for that is that trying to wrap a 10 gauge wire around a binding post and solder it, it's going to be a pain in the bum. So if I crimp it and then bolt it on, there's no heat involved. I'm not going to melt the connector or anything. End up melting the wire, like the insulation off the wire, because I've got to put so much heat in, and that'll make a really good connection there. Same with the switch. I've got a screw down type switch, so I'll put crimp lugs on there of the appropriate size. Here we are, finally reached its final form. Also, you've got to be careful with these resistors. These are 100 watt resistors, but they're not strictly 100 watt depending on how you mount them. They're only 100 watts if they're bolted down to an adequate heatsink, like a reasonably high size heatsink. Free in air, I've looked at a few different data sheets and it seems that they're about half the wattage when they're free in air, and a little bit less if they're bolted to something that's not a heatsink, because you've got less airflow around them. That's why I've got this nice vented case with the bottom and top vents. I'm going to change these feet maybe for taller ones just to get a bit more space there, to get a little bit more airflow through there. But that's just what I had for now. I didn't want to scratch up the desk with all the screws. But yeah, so these are actually, as they're mounted, about 50 watts or so, maybe a little bit less depending on how much airflow I get through this case, because it's a little bit tight in there. But I've worked on 50 watts a resistor and added it all up, and I've got, you know, the 4 ohm, 200 watts because there's 4 resistors, 15 ohm is 100 watts because there's 2 resistors per bank there, and then the 0.6 ohm is 400 watts and 0.4 ohm is 600 watts because for the 0.4 there's more resistors in parallel. So just be careful of that when you're calculating things. Don't assume that because it's 100 watts on the label, it's not actually 100 watts unless, like I said, you bolt it down to a decent heatsink to suck the heat out. And we're ready pretty much to put it together. Put the lid on and call it quits. I will get my multimeter here, and we'll just double check to make sure our resistances are looking good. So put it on the ohm scale. First of all, we've got the 4 ohm here, so let's have a look at that. You got that in the screen there. Let's have a look. What do we got? 4 ohm, spot on. This is only like a couple of digit multimeter. It's not a super accurate one, but that is close enough for us anyway. Next one is a 15 ohm. And that is telling us 15.3, that's fine. Next one is another 15, 15.2-ish. I guess that, yeah, 15.2 and 15.2. And then the last one, we'll go to 0.6 ohm, 0.7. There's going to be a little bit of resistance in the leads, so that's fine. And 0.4 is 0.5 because, once again, there's going to be a little bit of resistance in the leads. 0.2 ohm. So yeah, we're fine. 0.1, 0.2 ohm in those leads. So that means we are spot on and we are done. Alright, I'll go get the TM5006 mainframe. We'll hook it up and start tweaking some dials. So I've got the load bank now connected to the mainframe. 2mm squared cable, so it's nice and thick so I don't get too much voltage drop. And they're connected to the power supply PCB with these fast on style spade terminals. They've got provision for the this connection. They've got the male version of the fast on connector there already, so these just plug on and good to go. It makes it real easy to connect. So I've got it connected up with the plus and minus 26 volts is to the 15 ohm banks, and the plus 8 volts is to the 0.6 ohm bank. The switch there can be switched up and down between 0.4 and 0.6 ohms. We're using 0.6 ohm because it's calibration. In the manual it states for the performance test you do it 0.4 ohm. And this one here we're not using because that's for performance testing as well. That's the 4 ohm for the plus minus 26 volts. But we're using the 15 ohms for the calibration. So this is all set up, ready to go. So I'll get some multimeters out and we'll hook those up and see what we find. Alright, let's turn it on, see what happens. So we've got 20 kilohertz, which is correct. And if we dial this one, try not to touch anything. I'm going to go clockwise until this starts to drop. Doing it straight away, basically. Oh, about there. That's definitely right, about there. So 2045. And we want to counterclockwise till we've gone down by 0.25. So 20.2 is what we want. Right about, oh, a little bit too much. Right about there. There we go. Nice. Perfect. Now if I turn that back up to 100, actually I've got to plug in another thing. I'll put it back to 100 volts and see what our voltage is on our 8 volt rail. Alright, let's see what we're getting on our 8 volt rail at full line voltage. Beautiful. That's good. 20.2 kilohertz. This is going to be a little bit different from what we read before because we've upped the voltage by 20%. Oh, yeah, 15% ish. So let's see what we got now. What's that? Negative 26.9. That's looking pretty good. That's 26 volt, and this is the other plus 26 volt, 26.5. Looking good. Fantastic. I'm happy with that. Oh, that is getting warm. All right, better turn that off. It's getting a little bit warm. What's that? 50 degrees? No worries. She'll be right. All right, that's it. So that is the load bank working. And now my chassis is calibrated. So what should I do with this thing now? Calibrate more chassis. No worries. Bit overkill. So that's going to sit on the shelf, and every time I need to do a calibration of some sort, I will be able to use this and get things nice and spot on. Beautiful. Alright, hope you found that interesting. Keep watching the videos. We'll see you next time.